Hi, geometry students. Mrs. Kroll here. I'm so sorry I'm not in today. My son has tested positive for COVID, so I'm going to be out all week and most likely Monday. So we're going to get through this week with some videos and some lessons. You can always email me if you have questions, and I'll incorporate your questions into the video. Reminder, the end of the quarter is this Friday. So if you miss any test quizzes, the classwork that we did for day 6 of Unit 4, make sure you get all that in to the sub, and I will make sure I grade it and get it in for the quarter. If it is a test or a quiz, you may do that during class time and then watch these videos in the evening or during a study hall. I'll post them all on Schoology as well. But just make sure you get everything in. You can also check SchoolTool and make sure I didn't miss anything. And if we need to get you a copy of something, we can do that. So just make sure that you're on top of everything. All right, so as we go through the day 10 lesson, I need you to obviously do your best, and I'm going to ask that the video is paused every now and then to give you some work time. So let's go ahead and do this warm-up. So I would like you to have the video pause right now, work on the problem. I'm going to jump in and see how we do. All right, on a large party tent, each corner pole is 12 feet tall. Each pole has a support rope that is staked into the ground 5 feet away from the base. Obviously not drawn a scale. So there's my pole, 12 feet, and then the rope is 5 feet away from the base. Determine the angle of elevation to the nearest degree from the ground to the top of the pole. So angle of elevation is always made with a horizontal, which would be this horizontal right here, in the line of sight, which is the rope. So this is the angle of elevation. Remember, angle of depression would be this horizontal, the same line of sight, and it would be right here. We don't need the angle of depression, but just to remind you. And they are always equal because of the parallel lines of the horizontals. All right, so how am I going to find this missing angle? Well, because I'm missing an angle in a right triangle and I have two sides, I'm going to use the inverse. And because I have the opposite and the adjacent, I know that's tangent. So the tangent of x equals 12 over 5. So I'm going to do the inverse of tangent of 12 over 5, and that's going to give me my x value, my angle of elevation. So I'm going to grab my calculator, go to a calculator page. I'm going to notice I'm in radians, so I'm going to click, change it to degrees, and then the tangent, it's inverse, and that's 12 over 5. So it's the nearest degree. I have 67 degrees. And that's it. All right, here are your homework answers. Once again, go ahead and pause the video, take a look. If you do have any major questions about these, like I said, send me an email. Mrs. Kroll, I need to go over number 3, and then I'll include number 3 in one of my videos coming up. All right, just make sure you tell me which homework it's from. All right, so day 4, we're going to use the Pythagorean theorem to find what a word, sorry about that. Oh my goodness, let me try one more time. Trigonometric ratios. It's a mouthful. And we're going to use the Pythagorean theorem to do this. So looking at our right triangle we have right here, here we have theta. And if this is the theta I'm looking at in my right triangle, then we have our opposite, we have our hypotenuse, and we have our adjacent. So that means that the opposite squared plus the adjacent squared equals the hypotenuse squared, because a squared plus b squared equals c squared. So we're going to be given one trig ratio, and then we're going to use it to find all the other lengths of, the other length of the right triangle. And then from there, we'll be able to find all the trig ratios. So this is similar to what we've already done. We're just going a step further and finding the other trig ratios. All right, move this out of the way. Here we go. In a right triangle with an acute angle of a measure theta, sine theta is 1/2. Use the Pythagorean theorem to determine the value of cosine theta. So we have our right triangle. You should draw this every time. And I'm going to consistently put theta in the bottom right. I don't have to, but I just like to be consistent. And now I know sine and cosine and tangent. I can remember them with SOHCAHTOA. Sine is opposite over hypotenuse. Well, to find the cosine of theta, I need the adjacent over the hypotenuse. So I already know the hypotenuse, but I have to find the adjacent. So I need to find this missing side. So 1 leg squared plus the missing leg squared equals the hypotenuse squared. So 1 plus x squared equals 4. Subtract 1. X squared equals 3. Take the square root, and I get my missing side as radical 3. And I'm done. So that's what we're doing today. Feel free to pause if I move on too quickly and you didn't get a chance to write something down. 2. In a right triangle with an acute angle of measure theta, sine theta equals 7/9. Use the Pythagorean theorem to determine the value of tan theta. All right, so start with drawing that right triangle. Here's theta. Sine opposite over hypotenuse. Tangent. I need the opposite and the adjacent, so I'm missing that side again. So leg squared plus the other leg squared equals the hypotenuse squared. 49 plus x squared equals 81. I subtract 49 from both sides. X squared equals 32. And now I'm going to take the square root. And remember, how do I simplify that 32? I can go menu, number, factor, 32. And I've got 2 to the 5th. So there were a few people on the classwork we did that got confused with something like this. So I'm going to break up 2 to the 5th to be 2 squared times 2 squared times 2, because that equals 2 to the 5th. And anytime I have a perfect square, I can pull them out. So I have a 2 times a 2, and then a radical 2. So my answer is 4 radical 2. Remember, when I take out a 2 squared, I'm square rooting it, so that's why I'm left with a 2. All right, so this side is 4 radical 2. So the tangent of theta is opposite over adjacent. And I can't leave my answer like that because there's a radical in the denominator. So remember, I can multiply by radical 2 and divide by 2. So 7 radical 2 over 8. Or I can show that work, the radical 2 over radical 2. So 7 radical 2. And then remember, 4 radical 2 times radical 2 is really just 4 times 2, which is the 8. So there's my answer. 2. It says if tan theta equals 5, find the sine and cosine. So once again, I'm going to draw my right triangle. And I've got my right angle, my theta. And tan, as we just mentioned, is opposite over adjacent. So I only have a number here, but I always can put a whole number, or an integer, I should say, over 1. So opposite is 5, adjacent is 1. So I need to find the hypotenuse. So 5 squared plus 1 squared, those are my legs squared, equal my hypotenuse squared. 25 plus 1 equals x squared. 26 equals x squared. Take the square root. And x is radical 26. All right, now I get to write down the sine and cosine. So sine theta, remember sine is opposite over hypotenuse. And cosine theta is adjacent over hypotenuse. And both of these, unfortunately, have that radical 26 in the denominator. See if you can rationalize the denominator before I can. I'll give you just a moment. So I have 5 radical 26 over 26. And the other one, radical 26 over 26. So those are your final answers simplified. Next, we have if cosine theta equals radical 5 over 5, find the sine and tangent using the Pythagorean theorem. All right, so draw that right triangle. Here's theta. Cosine. Go ahead. See if you can get this one by yourself. In fact, why don't we pause this one and see if you can set it up. All right, I'm going to jump in. So cosine I know is adjacent over hypotenuse. So adjacent is radical 5. Hypotenuse is 5. And I have to find the other side here, this opposite side. So radical 5 squared plus x squared equals 5 squared. So 5 plus x squared equals 25. Subtract 5. X squared equals 20. Then I'm going to take the square root of both sides. X equals, menu number factor, 2 radical 5. Because radical 20 is 2 squared times 5. So out comes that 2. All right, so now I've got the sine of theta equals the opposite, that's that x that is found, over hypotenuse. So that one's simplified. And the tangent of theta equals the opposite over adjacent. Notice those radical 5s divide out, and I'm left with 2. All right, number 5. Once again, I will give you a moment to set this up, so go ahead and pause, give it a try. All right, so we're given the sine. So sine we know is opposite over hypotenuse, so 4 radical 29. And then my hypotenuse is 29. So make sure you have them in the right spot. All right, from here, I need to find, because I'm looking for the tan and cosine of the angle, I have to find that adjacent, so I'm going to call this x right here. All right, a lot of you made a mistake on the quiz on a similar problem like this. So I have the leg squared plus my side squared equals the hypotenuse squared. So what you forgot to do is you forgot to put parentheses around the 4 radical 29 in your calculator. I think you just put 4, you went like this. Obviously it was a different problem. You went like this with your calculator. So what's happening? Your calculator is even showing you what's happening. You're not squaring the 4. So that 4, if you're going to use your calculator, has to go inside. Oh, okay, it doesn't want to go in there. All right, it doesn't want to go in. So let's try typing it like this. 4 and then radical. There it goes. Now it's inside. So now I'm going to get the right answer. Without using your calculator, what's happening here? I'm squaring the 4, but when I square the radical 29, that undoes the radical. So I have 16 times 29. And then 29 squared 841. So I have 841. And then 16 times 29, what was that? 464. So I hope that makes more sense now. You will get your quizzes back when I return. I'll definitely go over them before you take the test. So I'm going to subtract now. So x squared equals, got 7. So we got 377. Take the square root. Radical 377. Now I should mention that every time you take the square root like I'm doing here, it's technically plus or minus. I'm not concerned about the negative right now because I'm talking about side lengths of a triangle. So we're going to stick to the positives, but technically there is that negative answer as well. All right, so we have that radical 377. That's my adjacent side. And they wanted me to find the cosine and tangent of this angle. So let's start with tangent. So tangent, remember, is the opposite over the adjacent. And my cosine is the adjacent over the hypotenuse. So looking at these two, my cosine's fine. It's simplified. If you are unsure, menu number factor for 377, and you'd be good. And then for the tangent here, we do have to do some simplifying here. So let's grab another page. So we have the tangent of the angle equals 4 radical 29 over radical 377. So one thing I might notice is that radical 29 can actually divide into radical 377, and that's just going to make the numbers easier for me. So if I take 377 and divide by 29, I can see it goes in 13 times. So that means I can divide radical 29 by itself and radical 377 by radical 29. So I'm just dividing by radical 29, that common factor. I know it's weird because it's a radical, but that's all I'm doing. And I've got 4. And then when I divide here, I get radical 13. And now I just have to rationalize the denominator by multiplying by radical 13 over radical 13, which we know just means that it's the numerator times radical 13 divided by 13. So there we go. There's our tangent. A little more work having to simplify it. All right, so your homework tonight is the day 10. The sub will be checking your homework each day, so please make sure you have it on your desk and you're ready to go. If you have any questions, please see me. And I hope you have a good week, and I look forward to seeing you as soon as I can. All right, take care, everyone. Bye.